I am Mr. Ish. Thank you for joining me for this video. I hope you're all having a great evening. In this video, we have to do this simple exercise. We have to prove that all circles are similar. We're not saying that all circles are identical or congruent because they wouldn't be. To be congruent or identical, the circles would have to have the same radius. When you're looking over here, this can be circle A and this can be circle B. You know their radii are different. One has a small radius, the other one has a large radius. One is a large circle, the other one is small. They are not congruent, nor are they identical, but they are certainly similar. And how would you go about showing that all circles are similar? Well, it very well has to do with this fact that they are, in terms of appearance, they all look like circles. With regards to the definition of a radius, from the center of that circle to any point on that circle, each circle has a certain fixed radius which never changes. For this specific circle, the radius here can be whatever, but in all instances, anywhere you look around, the radius will never change. And look, no matter how large or how small the circle is, the radius for that circle stays fixed no matter what point you look at on that curve. So this fact right here is always fixed for all circles because that property stays the same for each circle and their appearance in all instances stays the same. You can say that all circles are similar, but let's show it to you in a different way. If you can show that properties for different circles are always in defined ratios, you can say that they're similar. Look over here at this. The area of circle A is pi r squared. Let's call this r1 and we'll call this r2. The area of circle B would be pi r2 squared. We can put this r1 squared and r2 squared. If we were to take the large and divide it by the small, you're looking at area A and you're looking at area B, and you were to divide them, you have pi r1 squared divided by pi r2 squared. The pi's cancel out, you'd have r1 squared divided by r2 squared, and you end up seeing a ratio over here, and that ratio appears to be like a fixed ratio. For these two, this ratio would never change because their individual radius for each of these circles would never change. Now look again here, but at the concept of circumference. The circumference of A would be 2 pi r1. The circumference of this circle B would be 2 pi r2. If you were to take the large circumference and divide it with the small one, you'd have CA over CB. You'd have 2 pi r1 divided by 2 pi r2. The 2 pi's would cancel out. You'd have r1 and r2, and here you'd end up with another fixed ratio. Here you have a fixed ratio, here you have a fixed ratio. I'm calling them fixed ratio or a constant ratio because for these two circles, this value and this value, that value will never change. Therefore, the ratio will never change. Likewise, take any number of circles, large, small. We're not taking identical circles because we're not showing that they're identical or congruent. We're only looking here at similar. So take any number of circles, two circles or whatever their sizes might be, and you can always come up with fixed defined ratios for those circles, and those ratios would never change because their inherent properties would never change. Therefore, you can say that all circles are similar to one another, and let alone the fact that in appearance they look similar. They have a circle with the fixed defined points around a center of a given radius, and that property of a circle never changes from one circle to the next. Hence, you've proven that all circles are indeed similar. Thank you for watching. Have a nice day.